Hello and welcome to all the maths champs and aspirants of EAMCET. I'm trying to actually make a video on very important aspect. I'm not going to actually solve anything, but I'm saying that there are certain small mistakes, but we call it as big mistakes. Uh, to avoid those mistakes, what are those mistakes we generally encounter? That is what is my intention in this video. So this I'm calling it as episode 5 in EAMCET. Okay, what is EAMCET episode 5? Top 10 most common mistakes we commit in trigonometric functions and identities. What are these? See, let's see one by one. See, the number one mistake what we generally try to make is here misusing the what do you call trigonometric identity. See, sine square theta plus cos square theta is equal to 1. We often forget this and we often write sine theta plus cos theta also is equal to 1, but which is a blunder, which is a blunder. So this is the common mistake. Please do remember and forget. Sometimes we forget also that the sine square theta is cos square theta is equal to 1. Okay, what is the next one? If you just see what is this particular aspect of this is students makes this 1 plus tan square theta equal secant square theta, 1 plus cot square theta is equal to what we have written cosecant square theta plus generally the mistake we make is 1 plus tan square theta is equal to we write it as cosecant square theta, which is obviously a wrong thing. Okay, which is obviously a wrong thing, but you should be in a position to actually what do you call look at it and then not commit such mistakes. Okay, now this is highlight of all the mistakes what we see in regular, even sometimes I am trying to do mathematics more and more and more, but even I tend to do if we see an expression like that, canceling the expression sin theta directly, it is not the correct way. Instead, this particular approach, what does it say? We need to actually split it. So sin theta by sin theta plus cos theta by sin theta. So this is what is approach. Now this becomes 1 and this becomes cot theta. Generally, we try to cancel incorrectly. This is not the correct way of if I directly do this like this is not the correct way of then the answer would be cos theta, which will be wrong. Okay, see, this might not be a direct question in the MCET, but this comes as one of the step in when you are solving a question. Now, see, this is again one more area where you need to actually observe. See, this we have 1 by 1 plus sine theta. Often we need to rationalize this. So, when you rationalize, we need to take a conjugate of this and you get like this. Then further, numerator becomes 1 minus sine theta but denominator is something like a plus b into a minus b. We can write 1 minus sine square theta. But what is 1 minus sine square theta? Cos square theta. Again, there is a simplification further you can do. Okay. So let us come to the fifth one. Forgetting to check whether cos theta is equal to 0 or not equal to 0. If it is equal to 0, you cannot directly divide by cos theta. That you should be in a position to remember. If theta is given as 90 degrees, cos 90 is 0, then you should not divide with this particular thing. Next one. See, expansion of such particular, sine of a plus b or a minus b wrongly. See, sine of a plus b is equal to sine a cos b plus cos a sine b, but we generally we write sine a plus cos b, or simply we write sine a plus sine b. So which will be wrong. So this is again one most biggest mistake we make. And forgetting double angles. See, this particular EAMCET loves it. Actually, EAMCET is all about the sine 2 theta and cos 2 theta. Sine 2 theta and cos. What is sine 2 theta? 2 sin theta cos theta. What is cos theta? 1 minus 2 sin square theta is equal to 2 cos square theta. It can also be written as in other form cos square theta minus sin square theta. So cos of A plus B, you can write cos A cos B minus sin A sin B, right? So if I say A and B are same, so it becomes cos square theta minus sin square theta. It can also be written as cos square theta minus sin square theta. So cos 2 theta has different forms. Sin theta has only one form. So be very careful. And these two can also be written in terms of tan theta also. That is also very important while doing differentiation. Very importantly, right? Now let us see the other mistake, common mistake we try to this. I don't say this is a mistake, but this is a requirement. When you see in what you call a problem with mix with sine, cos, tan, and cot, convert everything into sine and cos first. Then it will be easy for you to do. If you directly try to attempt, and then you'll be end up in mistake. See, wrong use of complementary angles. Generally, when we say complementary angles, what is complementary angle? 90 degrees. So when you say complementary 90 degrees, sine becomes cos, tan becomes cot, like that. Even 90 can be written as the radius as pi by 2. Even then, it's a complementary angle. Now let us come to the 10th one. See, generally there are certain things are there where we need to transform the given expression into the or to actually write the exact answer for us, given the options. So sine theta plus cos theta, if you see, I can write root 2, I can take common 1 by root 2 sine theta plus 1 by root 2 cos theta, right? Then I'm making it as sine A cos B plus cos A sin B form. So you can write root 2, I can write, cos 45 sine theta plus sine 45 cos theta. I can write this, or I can write sine theta sine 45 plus cos theta cos 45. And then I have to convert into sine A plus B or sine A minus B. Okay. Okay, not only 10, I'm giving you two more here. What is the 11th one? I'm trying to actually tell you. 11th one is nothing but, 11th one is square root. Square root, generally square root of this. See, generally square root of 4, if you write 2, it will be going wrong. You should write plus or minus 2. Okay. In many sums, we get radius square is equal to, suppose say 4. Now r is equal to plus or minus 2. But radius of a circle cannot be minus, right? So radius of a circle should be plus. But if it is given in the quadrant, first quadrant, second quadrant, then also the length, radius is only length, right? What is the 12th one? I'm giving you another one, misunderstanding periodicity. See, this is again one more thing here. The sine of theta plus 2 pi. That means 2 pi is 360. 360 plus theta comes into the first quadrant. First quadrant sin theta is positive. Cos of 2 pi plus theta. 2 pi plus theta comes in the first quadrant. That again is a positive. But here again, if you write 2 pi, the sign will become sine, will remain sine. If you write pi, that ratio will become the same. But when you have to check whether it is first quadrant, second quadrant. Tan pi plus theta. Pi plus theta comes in third quadrant, only tan theta is positive. So tan of pi plus theta will becomes tan theta. Okay, so these are the very biggest mistake. I will say, though it looks very simple, they are very biggest mistakes. Reach out to me. I've given my details here. If you like the video, please do comment. Please do comment, like it, and then subscribe also to the channel so that I can make more such videos to you, so that you don't mistake or commit mistakes in choosing the correct option. Okay. I'll come with more such strategies in different topics like this. Okay. Directly solving the problem is not a big mistake. As of now, you are a senior intermediate and you have gone through 10th intermediate first year. You are accustomed to actually this particular pressure, and you are aspirant of EAMCET. That is really nice. Wish you all the best. I'll see you again in the next video. Bye.